This video explain on correlation analysis.
Look at the three scatter plot diagrams with the regression line drawn on it. The scale used for the diagrams are the same. Which of the three diagrams shows a strong negative linear relationships?
A moderate negative linear relationship.
A weak negative linear relationship.
If your answer is as follows: strong negative linear relationship, moderate negative linear relationship, weak negative linear relationship, then you are right.
This is correlation analysis. In correlation analysis, we are measuring the strength and direction of a linear relationship between two variables.
The strength of correlation between two variables is measured by correlation coefficient denoted by R. R range from -1 to +1. For this scatter plot, R is equal to -1. And the interpretation: perfect negative correlation between the two variables.
For this scatter plot, R is equal to -0.5. And the interpretation: moderate negative correlation between the two variables.
For this scatter plot, R is equal to -0.2. And the interpretation: weak negative correlation between the two variables.
For this scatter plot, R is equal to +1. And the interpretation: perfect positive correlation between the two variables.
For this scatter plot, R is equal to +0.5. And the interpretation: moderate positive correlation between the two variables.
For this scatter plot, R is equal to +0.2. And the interpretation: weak positive correlation between the two variables.
This diagram summarizes the strength and direction of the correlation coefficient.
The coefficient R is called Pearson's correlation coefficient. It is calculated as follows.
Example: calculate Pearson's correlation coefficient. Interpret the value.
You can verify that the sample size n is 10. Sigma x is equal to 196. Sigma y is equal to 651. Sigma x square is equal to 4124. Sigma xy is equal to 13,341, and sigma y square is equal to 43,739.
We will get R to be equal to 0.9385. The interpretation is: there is a strong positive correlation between assessment score and final score.
Another type of measurement that can be used to measure the strength, but not the direction, of a linear relationship is coefficient of determination. It is a ratio between the variation of the dependent variable that can be explained by the regression equation, compares to the total variation of the dependent variable.
If all the paired points fall on the regression line, then the variation of the dependent variable due to regression is equal to the total variation of the dependent variable, making the ratio equals to 1. Hence the ratio of 1 or close to 1 would indicate that there is a strong correlation between the two variables.
We can calculate the coefficient of determination by taking R square.
Example: given R is equal to 0.9385. R squared is equal to 0.9385 squared, which is equal to 0.8808. To interpret, we say that the variations of the final score is 88.08% influenced by the variations of the assessment score. The other 11.92% is influenced by other factors. Thank you for watching.